Hello everyone, I'm BaeTi, the math teacher from Korea. I have created an English version of the history of mathematics. I asked the English teacher for narration. Ashley?
This is the Great Mathematics History Time Machine, where we explore the history of mathematics, which has been a significant part of humanity. Today, we'll take a speedy time machine and I'll show you the watershed moments in mathematics history. Here's a sneak peek of today's show. The origin of mathematics and the development of numbers. Ancient Greece, the golden era of mathematics. The Middle Ages, the dark age of mathematics. Pre-modern Europe, the revolutionary period in mathematics. Modern mathematics, uncertainty and fusion. Let's begin our journey. During prehistory, humanity first came up with one-to-one correspondence instead of numbers or arithmetic. One-to-one correspondence is similar to the method of checking how many cattle there are by placing pebbles one by one, or like tallying up the result of a class president election at school, where votes are marked in groups of 5 using slashes. This can be seen from the slash marks carved on the ribbon from Swaziland, estimated to be 40,000 years old, and the Shangu bone from Congo, estimated to be 20,000 years old. Subsequently, humanity conceived the concept of a single unit, namely 1, and by accumulating this unit, they created the natural numbers 2, 3, 4, 5, and so on. The first recorded use of numbers was discovered in the cradles of civilization, Egypt and Mesopotamia. The Nile, also known as the lifeline of civilization, flowed through Egypt. The ancient Greek historian Herodotus once said, "Egypt is the gift of the Nile." The Nile River periodically flooded due to heavy rains on the Ethiopian plateau. To predict these floods, Egyptians had to develop their calendar and mathematics. The flooding also erased land boundaries, necessitating the development of a discipline to measure land size, known as geometry. The word geometry is a combination of geo, which means earth, and metry, which means measurement. Meanwhile, the Nile River also bestowed upon Egypt the gift of papyrus, a reed-like plant. When the stems of papyrus were flattened and dried, it became possible to write on them, much like modern paper. The word paper today derives from papyrus. The earliest mathematical text in Egypt is the Rhind papyrus, created around 1600 BC. Ahmes, a scribe at the time, recorded in it the decimal system, fractions, the volume of a cylinder. Although he used the decimal system, each number was represented by hieroglyphs, making it a cumbersome notation. The number 1 was represented by a vertical stick, similar to today's numeral 1. The number 10 was denoted by an arch shape resembling the modern symbol for intersection. The number 100 was depicted with a shape similar to a mosquito coil. Representing the number 345 in the notation of that time, it looked like this. It was quite inconvenient. Now, let's move to Mesopotamia. The word meso means between and poten means river. Thus, Mesopotamia means land between rivers. Just as the Nile River shaped Egypt, Mesopotamia was born between the Tigris and Euphrates rivers in what is now Iraq. Unlike the Egyptians, who recorded mathematics on papyrus, the Mesopotamians used sharp cuneiform script to inscribe their mathematics on clay tablets. Clay tablets were heavier and more cumbersome than papyrus, but they had greater durability, allowing them to preserve records clearly for future generations. The cuneiform inscriptions on clay tablets from that era show that Mesopotamians used a sexagesimal numerical system. There are various theories as to why they choose 60, but a prominent reason is that 60 is a highly useful number, having 12 divisors. This influence persists today as we still use 60 seconds in a minute and 60 minutes in an hour. As humanity developed numerals alongside civilizations, the number systems of Egypt, Mesopotamia, China, and Rome lacked positional values, leading to cumbersome calculations. The numerals we use today, known as Arabic numerals, were originally invented in India. They were later disseminated by Arab traders, which is why they came to be called Arabic numerals. Brahmagupta, a mathematician from India, is credited as the first to officially use the number 0 in mathematics. The positional numeral system of Arabic numerals, including the number 0, brought about a revolutionary change in calculations. Without 0, it had been challenging to distinguish between numbers like 12, 102, and 120. Today, the most universal language used around the world is not English or Chinese, but Arabic numerals. They are considered one of humanity's greatest inventions. This picture is the School of Athens, painted by Raphael, who was one of the 3 great masters of the Renaissance period. Here, the painting gathers great scholars who sparked the golden age of knowledge from around 500 BC to 400 AD, spanning from Athens in Greece to Alexandria in Egypt. How could remarkable individuals like this have come together here? The rich climate of the Mediterranean brought many people together in the Agora for discussions, which fostered development of logic and democratic spirit. Additionally, the prosperity brought about by the development of maritime trade in the Mediterranean created an atmosphere conducive to intellectual pursuits, naturally leading to the advancement of philosophy and mathematics. Mathematics in ancient Greece began with Thales. Prior to Thales, there was empirical mathematical knowledge in Egypt and Mesopotamia. But it was with Thales that deductive mathematics, which verifies theories through proof, started. Following Thales, Pythagoras emerged not merely as a mathematician, but as the leader of the Pythagorean school, a group that believed in the principle that all is number, suggesting that numbers are the ultimate basis behind everything in the universe. The Pythagoreans believed that everything in the world could be represented by natural numbers or the ratios of natural numbers, which are rational numbers. However, the Pythagoreans, through their greatest achievement, the Pythagorean theorem, discovered the existence of irrational numbers when they realized that the ratio of the sides of isosceles triangle is 1 to 1 to square root of 2. But the existence of irrational numbers contradicted their religious belief that all quantities could be expressed as rational numbers. This contradiction led to a dramatic episode where Hippasus, a member who diverged his discovery, was reportedly drawn by other members of the sect for revealing the secret. Euclid and Archimedes were the twin luminaries of the Greek era. Euclid is best known as the author of Elements, a textbook on geometry. The greatness of this work lies in its consolidation of 465 theorems into just 13 volumes, all derived from just 10 axioms. This accomplishment is akin to conquering an empire of mathematics with only 10 swords. Additionally, written about 300 BC, this book forms the basis of today's middle and high school geometry textbooks. It's remarkable that a book created during the era of ancient Gojoseon in Korean history to continue to be used as a textbook to this day. Archimedes is considered the original mechanical engineer, famous for shouting "Eureka" as he ran out naked while trying to determine if a crown was pure gold. He famously claimed, "Give me a long enough lever and I will move the earth." Archimedes left numerous iconic moments and inventions in the history of science and is today regarded as one of the three greatest mathematicians alongside Gauss and Newton. The era of ancient Greece, which began in Athens, reached its zenith in Alexandria, a city named after Alexander the Great, who conquered the Mediterranean at young age and died prematurely. At that time, Alexandria, Egypt's largest port city, was illuminated by the Pharos lighthouse, facilitating the exchange of Eastern and Western cultures. The city was home to the Great Library of Alexandria, estimated to have housed between 200,000 to 700,000 scrolls. This library was a hub of knowledge comparable to today's Google, attracting scholars from around the world. Scholars such as Euclid, Archimedes, Eratosthenes, Pappus, and Hypatia, the first non-female mathematician, all passed through the Great Library of Alexandria. Studying just these individuals who were associated with the library would provide a substantial understanding of ancient mathematics. However, a dark shadow was cast over Alexandria in 313 AD when Roman Emperor Constantine declared Christianity as a recognized religion with the Edict of Milan. This marked a significant shift in the religious and cultural landscape of the Roman Empire, impacting Alexandria and its intellectual institutions. Subsequently, in the year 415 AD, the philosopher Hypatia was brutally murdered by Christian zealots, an event often likened to a witch hunt. This led many scholars to flee Alexandria. Following these events, a period ensued where divine authority and religious doctrine were prioritized over human inquiry and scientific endeavor, marking the start of what is often referred to as the Dark Ages, a millennium where religion overshadowed science. From the 4th century AD until the full onset of the Renaissance, Europe experienced a millennium dominated by the age of religion. During this time, religious institutions held significant influence over intellectual, cultural, and political life. The word philosophy is derived from the Greek words philos, or love, and sophia, or wisdom, meaning the love of wisdom. Originally, it conveyed a sacred connotation of cherishing knowledge and seeking intellectual enlightenment. However, it seems that medieval philosophy was meant to express a love for religion, so much so that Thomas Aquinas said, "Philosophy is the handmaiden of theology." Thus, the Middle Ages are called the Dark Ages in the history of science and mathematics. During the Dark Ages, mathematics clung to life in Islam, where algebra developed, and Italy, where trade flourished. In the medieval period, the representative mathematician of Islam was Al-Khwarizmi, known as the father of algebra. The word algorithm originates from Al-Khwarizmi, and part of the title of his book, Al-Jabr, is the origin of the world algebra we use today. Italy, situated on the route from the Mediterranean to Europe, played a role in transmitting the cultural and intellectual goods of East and West. In particular, the Liber Abaci by Fibonacci became a bestseller, spreading the use of Arabic numerals and the golden ratio of the Fibonacci sequence throughout Europe. Meanwhile, as the bubonic plague, which prayer could not cure, spread, religion was losing trust in Europe. The Renaissance, Reformation, and Industrial Revolution were looming. The term Renaissance means re or again plus naissance or birth to mean rebirth, referring to a revival of the culture and knowledge of ancient Greece. Mathematics, which had been a dark age for 1,000 years, was also preparing for the Renaissance. Pitt began using letters for unknowns. Napier invented logarithms, extending the life of astronomers, and this argues productive geometry introduced perspective and vanishing points to Renaissance paintings. With the cogito proposition, I think, therefore I am, the philosopher Descartes, who ushered in modernity, created analytic geometry, which combined algebra and geometry. Now, shapes could be expressed as formulas and moving objects as coordinates, giving scientists wings. In the 17th century Europe, scientists were concerned with how everything in the universe moved. And Newton, history's greatest scientist, explained this with the formula F equals ma. However, a clearer tool was needed to explain motion, so Leibniz and Newton created calculus, which mathematically explained the motion and was one of humanity's greatest inventions alongside Arabic numerals. Without calculus, not only today's cars and airplanes, but also gaming and smartphone operations would have been impossible. Later, calculus was further rigorously developed into the field of analysis by Weierstrass and Koch. The epsilon delta argument is a typical tool of analysis that torments college students in science and engineering. In the 16th century, algebra saw challenges regarding the general solutions or root formulas of cubic and quadratic equations. The solution to the cubic equation was developed by Tartaglia but became known as Cardano's solution because Cardano published it. The solution to the quadratic equation was found by Ferrari, a student of Cardano. 300 years later, in the early 19th century, two young genius mathematicians, Abel and Galois, proved that a general solution for quantic equations does not exist. In particular, Galois, at the age of 20, created a revolutionary tool called the group, which he used to prove that there is no general solution for quantic equations. In algebra, the complex numbers were extended by Hamilton's invention of quaternions. Galois' group theory and Hamilton's quaternions laid the foundation for the development of abstract algebra. Meanwhile, in geometry, many mathematicians began to question the parallel postulate, which had been considered an absolute truth in Euclidean geometry. The parallel postulate states that for a given line L and a point P not on it, there is exactly one line through P that is parallel to L. However, if it's assumed that there are infinitely many lines through point P that are parallel to line L, then hyperbolic geometry developed by Bolyai and Lobachevsky comes into existence. Conversely, if it's assumed that there are no lines through P parallel to L, then spherical geometry created by Riemann comes into existence. Doubting Euclidean geometry, which had been the absolute authority for 2,000 years, led to the birth of non-Euclidean geometry. Additionally, topology, a type of geometry that considers shapes that can be stretched or shrunk like rubber as equivalent if they can be transformed into one another without tearing, was developed. Euler's seven bridges of Königsberg, the Moebius strip, and the Klein bottle are famous topics in topology. Thus, pre-industrial modern European mathematics was characterized by the development of calculus, abstract algebra, and non-Euclidean geometry, and produced superstar mathematicians like Gauss, Euler, Koch, Riemann, Poincaré, and Hilbert, who were outstanding in various fields of science. Later, the differential geometry developed by Riemann became the foundation for Einstein's general theory of relativity, and Hilbert's spaces became the foundation for quantum mechanics. The Second International Congress of Mathematicians in Paris in 1900 is famous for Hilbert's 23 problems, which included challenges such as Goldbach conjecture and Riemann hypothesis. Hilbert left 23 significant problems for the 20th century. On Hilbert's tombstone is written his famous quote, "We must know, we'll know." He was confident that although his generation might not solve all problems, future mathematicians would certainly be able to. The boundary of the modern mathematics era is unclear, but personally I believe the foundation of modern mathematics was established when Hilbert presented his 23 problems and Cantor developed set theory. Cantor advanced the concept of sets beyond its just collection, turning it into set theory, and is a legend alongside Dedekind in creating the current real number system. Moreover, De Morgan, known for De Morgan's laws, and Russell, famous for Russell's paradox, were masters of mathematical logic. The early 20th century was a time for reorganizing the foundation of mathematics through set theory and mathematical logic. However, Hilbert's belief that all problems could be solved was devastatingly undermined by Russell's paradox and Gödel's incompleteness theorems. Modern mathematics and science entered an era of uncertainty, where absolute truths were elusive. The advancement of mathematical logic and science led to the emergence of computers, giving birth to legendary computer mathematicians like John von Neumann, known for game theory, and Alan Turing, who cracked the German Enigma code. Claude Shannon, the father of digital and bit, created the concept of information entropy, bringing information into the realm of mathematics. Thanks to this, vast amounts of modern data are digitally preserved in combinations of zeros and ones, ensuring that even 1,000 years from now, videos of Blackpink's performances can still be vividly viewed. The four-color theorem, which states that a map can be colored with just 4 colors, was proven by computer by Apple and Hagen. Complex systems mathematics like fractals, chaos, and fuzzy theory have explosively developed through the use of computers. As modern mathematics has become a more specialized and advanced, mathematicians have entered an era where if it's not their specialty, they just say, "I don't know much about that." However, just as Descartes integrated algebra and geometry 400 years ago, modern mathematics has put a lot of effort into integrating its various specialized fields. A prime example of this is the Langlands program. Like Einstein's attempt at a unified field theory to integrate various natural forces, the Langlands program suggests that combining seemingly disparate fields of mathematics can lead to solutions to problems. Fermat's last theorem, which troubled mathematicians for 350 years, was proven in 1995 by Andrew Wiles. Wiles was able to make this historic proof through the Langlands program, which integrates elliptic curves, number theory, and follows group theory. Today, mathematics is not confined to its own realm. Theoretical physicist Edward Witten, known for string theory, won the Fields Medal, often referred to as the Nobel Prize of Mathematics. And mathematician John Nash won the Nobel Prize in Economics. Modern mathematics extends beyond itself into various academic disciplines as well as industry and the arts. Steve Jobs once said, "The ability to combine art and engineering made Leonardo da Vinci a genius." It may sound like self-praise, but this is certain. The success of Steve Jobs and Elon Musk is the epitome of modern civilization, which has sublimated technology, history, and art. At the foundation of all this was mathematics. Oh, mathematics! Who created it, and what has it left for humanity? The mathematical concepts that changed the world can be found in the Mathpresso book.
Did you have a good time? This has been BaeTi, your math barista from Mathpresso Cafe. Bye!